What's going on, guys? So I wanted to make a really quick video on the game loop, explaining the game loop. It's a pretty, I wouldn't say it's complicated, it's hard to explain. Actually did a couple of videos before this, and I just kept deleting them because I thought it was just confusing. But I'll try my best to explain. Um, and yeah, try to look at it yourself as I'm explaining. You can pause the video and keep trying to figure out what I'm saying or stuff like that. So all right, let's dive deep. This is a video for those of you who are interested into knowing why the game loop works or how it works. I know a lot of times you would just be given this game loop and be said, oh, you can just copy and paste this, but I'm a student. I do want to say, I do want to acknowledge I'm not like, a game coding expert or anything like that. But I looked into, this code and it did make sense. So I thought I would do a video on it. All right, so let's go deep. Dive right into it. First off, before diving in, I want to explain the difference between the method render and tick. And if you're doing a game loop, you need those methods. The render is responsible for just drawing onto the window. Um, it doesn't care. Now, for this game, I'm just going to go ahead and run the game. You can see that's a game, right? That's a parabolic jump right there. And if you're interested, that's the algorithm that I used to achieve that. And these are the variables. Okay. And the render is simply responsible for drawing onto the window. And it simply positions the box onto, the X value, the Y value. We don't update the width and the height in this game. And the X and the Y values are manipulated in the tick method. So all your game algorithm takes place in the tick method. This is where, the parabolic motion or, whatever it is, this is where it's updated, okay? And by the way, velocity X is, where is it at? Okay, so that's where it's at. And I have a key listener, where is it at? Keyword handler. I have a key listener that is responsible for listening to the keys and updating the values of velocity X and velocity Y. If you're interested into replicating this game, that's just a bit of hint. Okay, so if we saw that the tick method is responsible for updating or manipulating the values of the X and Y, and thus, updating the position of the location of the box, right? And the render is responsible for simply drawing onto the window. Let's go back and go deep into the game loop. Okay, so first off, we have system.nanotime. That's just simply the current time from the system, and it returns a long value, so it's stored into a long variable right here into last time. Now we have the amount of ticks per second. Now a lot of times you would see it simply as amount of ticks, but I thought, you know what, to explain it better, I'm just going to add that per second. It simply represents the amount of ticks or the amount of time you're going to call the method tick in 1 second. That's so using this game loop, we're simply going to iterate into this loop. And by the way, the whole point of this game loop is to simply control the speed of our game. And so if you would just call, tick and render into a simple loop, what's going to happen is the speed of your game is going to be dependent on the speed of your, execution speed, on the execution speed of the program or your computer. And so for fast computers, the tick method is going to be called, so fast. And for slow computers, it's going to be slower. And so your game is going to be having a varying speed, right? Which is not good. It's not going to be consistent. But if you use a game loop, it's going to have a consistent speed. Additionally, it will give you, the control to control the power to control the speed of your game. So that's the whole point of the game loop, right? And so in this right in this game loop, we're going to be calling the method tick, which is responsible for updating the location of our box 60 times in 1 second. Okay, and that's stored in a double value right here, and that's because of the hang on, why is that? I think, I don't know, I guess you can store that. Okay, I think it's because of the division right here, because that value has to be double. Okay, because of the division that takes place right here. Okay, so that's a double value, right? Now, I want to get to this value because this may be confusing for many of you. So this, again, this is mostly represented as that in ns nanoseconds, but I like to have it like that because this is a nanosecond, or the second, or the time per one tick. Now, this value right here is simply 1 second, and that's in nanoseconds, 1 second in nanoseconds. If you go to Google, 1 second to nanoseconds, that's the value, which is exactly this value right here with 9 zeros. Okay, so 1 second divided by 60, right? But not necessarily 1 second, but like, this value right here in nanoseconds. What it's going to do is it's going to take this nanoseconds, which is equivalent to 1 second, and it's going to divide it into 60 chunks. And that one chunk is going to represent the amount of nanoseconds, or the amount of time it's going to take for one tick of those 60 ticks that are supposed to be in 1 second. Again, this represents 1 second, and if you divide this into 60 chunks, that one chunk is going to represent the amount of time it takes to just do one tick. Okay, I hope that was clear. If it was not, I would encourage you to just think about it, try to figure it out, or try to understand why it's that way on your own, try to understand the math behind it. Okay, let's go to delta. Delta is a difference. Now, I will come to this later on. This is the current time in milliseconds, and you just store it into a long variable timer. We're going to come to updates and frames later on. Okay, so we have while running, and this value is initialized to be true right here in the start of our program. So while running, right, and your program just enters to this loop automatically, you have the current nano time, and you store it into the variable now, right? So that's the current time, system.nanotime. Delta is a difference between now and last time. Now, last time was the time when this method was called. So it's pretty much the difference, the difference between now and last time, at least in the beginning of our program, is the time it took for the program to execute these commands right here and check this condition right here. And so that's this difference right here, right? And so now you may be asking, why in the world are we dividing that by nanoseconds per tick? I'll explain that. But if you understand now and last time, the difference is simply the difference of these two variables represents the time it took for the program to execute these commands right here. Or once, now that's for the first, iteration. But for the second one, the difference between now and last time, now right here you can see last time is automatically immediately set to, now is, how do I say this? Last time is set to the value of now. And the difference right here is going to represent the time it took for the program to execute these statements and go into the method tick and render as well, right? Once it gets into the loop, okay? So that's about this right here. Now, I will explain why we're dividing it by that. Now, there's a while loop right here. And this while loop is entered only and if only delta is greater than or equal to 1. If delta is at least 1, right? That's when this while loop is entered. If delta is below 1, it's not going to be entered. And in this while loop, there's a method tick, which is responsible for updating the position of our block. Okay? Now, think about it. Delta will be equal to 1 when this difference is equal to nanoseconds per tick. If these two values right here are equal, that's when delta is going to be 1. And notice, this is a summation. Now, usually the computer is very fast. So it will iterate through this loop numerous times before, and it will add on to delta, right? It's going to be like 0 point something, 0 point something, 0 0.5, 0 0.7, 0 point, 8, 0 0.8 point something, and I'm sorry, 0 0.8, blah, 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 right? And before actually, before delta becomes 1, it will go through several iterations because the computer is fast. And it's adding on to delta each time it does. Now, when delta is equal to 1, which means that the amount of time, right, it lasted as it was doing the loop iteration was equal to the nanoseconds per tick. And we talked about what that means. Nanoseconds per tick represents the amount of nanoseconds, the amount of time, that little one chunk, the amount of time it takes for one, tick, or to execute one tick, right? The amount of time you have to wait to execute one tick. And once this value, once delta becomes 1, once the execution time, once the time it took for the program to execute the statements or iterate through the loop is actually equal to that time, now delta is 1, and it will allow one tick, right? And it's going to subtract. Now imagine it was exactly 1, right? I mean, usually it may be like 1 point something, but it will be pretty close to 1 because the program is very fast. And it will subtract exactly 1 from delta and set it back to, 0 or 0 point something. And it will add, 1, exactly 1 to updates. And pretty much what updates does is keeps track of how many times the method tick was called. Okay, that's about this while loop right here. And we got the render right here. Now render, I don't understand, like, there's no problem with drawing onto our window every time the loop is, the while loop is being iterated, because this render is being called every time this, loop is being iterated. I don't know why they don't put it inside this loop right here. But render, I guess there's no problem with it, like, because the main thing that updates our block, right, or on whatever game you're building, the main thing that is responsible for updating or causing an update onto your window or your player or something like that is a tick method that's responsible for the algorithm, but render is simply responsible for the drawing. And so this is being called every time the while loop is iterating. And then we got frames that keeps track of how many times render is called. Okay. Now this, we got an if statement. We're almost done, guys. We got if statement right here, and it says if system.currentTime millis minus timer. Now timer was set right here. Okay. Now this is for the first iteration, obviously, because once after, like in the second iteration, the program doesn't even get to this, right? It's a loop, so it just gets to this right here. But system.currentTime millis, right? We got timer is greater than 1000. Now, because we're in the scope of millis, 1000 is equivalent to 1 second. So what it's saying is if 1 second has passed thus far, right? Add 1 second onto timer because 1 second has passed, right? And then print the frames, which is how many times render was called, and then the ticks, or how many updates were made. And then set frames back to 0 and updates back to 0. Because these values only represent how many times, you know, a tick was called and a render was called in only 1 second. So you set them back to 0. And you keep printing this every 1 second because of this condition right here. And the loop starts all the way back right here, and keeps going. Okay, I hope that was my best of explaining this. Let me know if this was not helpful or if it was helpful. But yeah, let me run it again. We got this, and if we would actually see the console, right? It's printing, and you can see it's doing 60 ticks exactly in 1 second. Now it may be a little off. Sometimes you can see like 59 or 61, right? And that's because currently my computer is like lagging for some reason. It's been doing that recently. But you can see that the loop is iterating like 2,000 something times, 2,700 times. Render is being called 2,700 something times, but tick is only being called 60 times per second. Do you see this? So that's the whole point of the game loop, is to not call tick or make an update, just based on the computer's performance, but to actually have a set speed, which is represented by 60 right here, right? It's only doing it 60 times per second. And that's what the game loop allows. It keeps it consistent. I hope this video was helpful. Thank you very much, and God bless.